Have you ever wondered if human civilization once possessed knowledge so advanced that it seems impossible even by today's standards? Imagine standing before a structure that was built thousands of years ago, yet aligns with the stars more precisely than modern observatories, or handling a tool whose sophistication seems to defy the technological capabilities of its time. Across the world, from the pyramids of Egypt to the ruins at Pumapunku in Bolivia, traces of such extraordinary ingenuity persist, quietly challenging our understanding of human history. These artifacts are more than just remnants. They are windows into a forgotten capacity for innovation, a reminder that intelligence, like energy, can be conserved and transmitted across generations in ways we are only beginning to comprehend. What if our ancestors' minds were exploring principles of engineering, physics, and material science that would only be rediscovered millennia later? And what does this tell us about the potential locked within our own brains, waiting for us to awaken it? The phenomenon of ancient advanced technology is not just a curiosity. It is a profound opportunity to explore the interplay between human perception, cognition, and the adaptive capabilities of the brain. Neuroplasticity, the brain's remarkable ability to reorganize itself in response to experience, suggests that our mental capacities are far from fixed. The creators of these sophisticated artifacts may have exercised a form of cognitive plasticity that allowed them to transcend the apparent limitations of their environment. Like neurons forming new connections to encode knowledge, entire civilizations may have developed systems of understanding that are invisible to us today. When we study these ancient technologies, we are not merely looking at stone or metal. We are looking at the crystallized outputs of a mind operating at a level of integration that modern neuroscience would describe as highly efficient, synchronized, and anticipatory. Consider, for instance, the precision stonework of Pumapunku, where blocks of andesite weighing multiple tons were cut with tolerances so fine that even contemporary laser cutting machines would struggle to replicate them. The joints are so exact that even a sheet of paper cannot fit between them. How did ancient engineers achieve this? Did they possess tools lost to time? Or did their minds develop a type of spatial reasoning and kinetic intelligence that allowed them to manipulate stone as if it were clay? Cognitive scientists today would describe such skills as involving a combination of procedural memory, embodied cognition, and advanced problem-solving strategies. When we witness such mastery, we are observing the physical manifestation of neural circuits optimized for a very specific purpose: the transformation of abstract design into precise material reality. This opens an intriguing philosophical question. If our ancestors could reach such heights of technical mastery without modern instruments, what does this imply about the limits of human cognition? Modern neuroscience tells us that the brain is a system of distributed networks, constantly integrating sensory input, memory, and predictive modeling to guide behavior. Yet the brains of ancient humans were anatomically identical to ours. The difference, then, may not lie in raw capacity, but in the ways in which attention, motivation, and cultural structures directed cognitive resources. The builders of megalithic sites, the creators of intricate tools, and the architects of complex rituals may have operated within a cultural and neurological framework that amplified their problem-solving abilities. In other words, the extraordinary technologies of the past may be as much a testament to collective neurocognitive optimization as to individual genius. Take the example of the Antikythera mechanism, discovered in a shipwreck off the coast of Greece. This intricate device, dating back over 2,000 years, functioned as a complex analog computer capable of predicting celestial movements and eclipses with remarkable accuracy. The sophistication of its gears, the understanding of orbital mechanics encoded in its design, and the precision of its manufacture all point to a level of knowledge that seems astonishing for its era. From a neuroscience perspective, constructing such a mechanism would require an advanced integration of abstract reasoning, working memory, fine motor skills, and anticipatory planning. It is as if the ancient mind was leveraging a form of cognitive multitasking that modern psychologists associate with expert problem-solving. The Antikythera mechanism is more than a device. It is a mirror reflecting the intricate dance between brain, hand, and the conceptual grasp of the cosmos. When we examine these ancient technologies through the lens of neuroplasticity and perception, a fascinating parallel emerges. Just as the brain adapts to new challenges by rewiring itself, ancient societies may have adapted their cognitive schemas to engage with materials and natural phenomena in ways that maximized efficiency and innovation. Think of the human mind as an energy network, with ideas traveling like electrical signals along synaptic connections. Cultural practices, apprenticeship systems, and ritualized learning may have functioned as feedback loops, reinforcing and optimizing these neural pathways. The result was a form of collective intelligence capable of achieving feats that, at first glance, appear almost magical. Our perception of these achievements as superhuman may in fact be a reflection of the biases inherent in our own cognitive expectations, conditioned by centuries of technological progression. Yet there is another layer to consider. Stress, as paradoxical as it may sound, can enhance cognitive performance under certain conditions. Neuroscientific research indicates that moderate levels of stress can promote synaptic plasticity and improve memory consolidation. In environments where survival depended on precise timing, acute observation, and practical problem solving, the brains of ancient humans may have been operating in a state optimized for learning and adaptation. Each challenge, the movement of a massive stone, the prediction of seasonal changes, the alignment of monuments with celestial events may have acted as a cognitive stimulus, enhancing the ability to detect patterns, solve complex spatial problems, and innovate under pressure. Perhaps what we interpret as ancient genius is, in part, the natural outcome of environmental and cognitive pressures that activated latent neural capacities. Consider as well the role of attention and focus in these accomplishments. Modern cognitive science shows that deliberate, sustained attention can alter neural architecture. Practices such as meditation, ritual, and prolonged apprenticeships may have been mechanisms for honing the mind's capacity to focus on intricate tasks. When a craftsman in the distant past carefully carves a stone or aligns a structure with the stars, they are engaging in a form of cognitive training that, while different from modern education, achieves comparable results in terms of neural refinement. It is as if the brain, when guided intentionally, can exceed expectations and unlock abilities that remain dormant in ordinary circumstances. The ancient world, then, becomes a laboratory not just of material artifacts, but of cognitive exploration. And here is the twist. The technologies we perceive as advanced may have been as much about managing perception as manipulating matter. Our ancestors were acutely aware of the limitations and potentials of human senses. They engineered environments, tools, and experiences that amplified the mind's capacity to interact with the world. For instance, acoustic properties in ancient temples and amphitheaters were not accidental. They demonstrate an intuitive understanding of wave phenomena, resonance, and spatial perception. By structuring experiences in ways that engage the brain's sensory and interpretive faculties, ancient technologies could enhance memory, focus, and learning. The mystical aspects of these structures may in fact reflect a deep scientific understanding of neurobiology long before the formal study of neurons and synapses existed. This raises another question. If we accept that the human brain has always been capable of extraordinary feats, are we underestimating our own potential? Modern neuroscience, with its insights into brain plasticity, working memory, and neural networks, suggests that the limits of human cognition are far from fixed. Ancient civilizations offer a blueprint, albeit fragmented, showing what is possible when environment, culture, and cognition align in a system optimized for learning and creation. Perhaps the greatest lesson of these technologies is not the artifacts themselves, but the implicit understanding of how the human mind can be cultivated to achieve remarkable things. In essence, the past challenges us to reconsider what we believe the human brain is capable of today. Moreover, these discoveries provoke a subtle but profound reflection on time, progress, and knowledge. We often assume that human understanding progresses linearly, that each generation builds upon the previous one. Yet the evidence of ancient advanced technology suggests a more complex trajectory, where knowledge can emerge, peak, and even fade from collective memory. Cognitive scientists might interpret this as a form of distributed intelligence where information is encoded across individuals, social practices, and material culture rather than solely in written records or formal institutions. The ebb and flow of knowledge across civilizations mirrors the dynamic networks within our own brains, where some neural connections strengthen, others weaken, and latent capacities remain dormant until activated. We also find parallels between the strategies of ancient engineers and principles of modern quantum thinking. In quantum mechanics, systems are understood not as isolated entities but as interdependent, probabilistic networks. Similarly, ancient technologies often demonstrate an integrative approach. Architecture, astronomy, material science, and human ergonomics were considered as a unified system. The builders understood, intuitively or empirically, that the behavior of the whole could not be reduced to the sum of its parts. This holistic perspective mirrors contemporary insights from neuroscience and systems theory, suggesting that the complexity of the mind, and by extension the civilization it generates, thrives when interconnectedness is recognized and leveraged. So, what does this mean for us today? Beyond the awe-inspiring artifacts and the historical intrigue, there is a practical lesson embedded in these ancient achievements. They remind us that human cognition is not a static resource, constrained by current technology or societal norms. Just as our ancestors adapted to their circumstances, experimented with materials, and honed their perceptual and motor skills, we too can cultivate the latent potential of our brains. Whether through focused practice, interdisciplinary thinking, or immersive engagement with complex problems, the capacity for innovation remains within reach. The ancient world offers not just artifacts but a challenge to expand our own mental horizons and engage with the universe in ways that honor the full complexity of the human mind. And here lies a subtle but powerful twist. The limitations we perceive are often protective mechanisms, evolutionary adaptations designed to conserve energy and prevent cognitive overload. When we feel stuck or incompetent, it may be our brain's way of guiding us towards safety or signaling the need for strategic focus. Ancient engineers and thinkers likely experienced similar constraints, yet they learned to channel these boundaries into productive, highly optimized cognitive processes. This suggests that the perceived gap between human potential and achievement is not a deficit, but a signal, a call to align attention, intention, and practice to unlock abilities that are otherwise dormant. As we reflect on these insights, it becomes clear that ancient technologies are not relics of impossibly advanced civilizations. They are evidence of the brain's extraordinary adaptability, the power of focused cognition, and the potential for human systems to achieve integration and efficiency far beyond what is immediately visible. They encourage us to reconsider our assumptions about intelligence, progress, and the interplay between mind and matter. By studying the past through the lens of neuroscience, psychology, and systems theory, we begin to see that the story of human innovation is not linear, but a complex tapestry of learning, adaptation, and emergent brilliance. In conclusion, the artifacts of ancient advanced technology are more than mere curiosities. They are reflections of human potential, crystallized in stone, metal, and mathematical precision. They remind us that intelligence is a networked adaptive system, capable of achieving extraordinary feats when environment, culture, and cognition align. They provoke us to ask deeper questions. How much of our own potential remains untapped? What latent capabilities lie dormant, waiting for the right conditions to emerge? And perhaps most importantly, how can we, in our own lives, harness the lessons of the past to cultivate a mind that is not only knowledgeable but profoundly creative, resilient, and attuned to the subtle patterns of the world around us? If this exploration of ancient technology and human cognition sparked your curiosity, take a moment to reflect on your own mental networks. Consider the ways in which your attention, memory, and perception are shaped by both biological wiring and the cultural environment. Imagine what could be achieved if you deliberately nurtured the plasticity of your brain, aligning your practices, focus, and learning with the systems that optimize human potential. And as you ponder these questions, I invite you to continue this journey with us here at MindSpark Science. Comment below with your thoughts. Share the video if it inspired you, and subscribe to the channel for more explorations at the intersection of neuroscience, psychology, quantum thought, and the philosophy of science. Together, we can uncover not just the secrets of the past, but the extraordinary possibilities of our own minds.